So you are welcome to this video. This is Sir Prince and this is Study by Yourself. Now in this video you are going to talk about naming of alkanes. How do we name alkanes? Now in my previous video of introduction of alkanes, I mentioned that you always use the longest chain, and I also spoke about the presence of substituents, that is organic substituents and inorganic substituents. So looking at this structure here, if you are new to this, you might not recognize this, but I want to simplify it. So this is actually the structural formula. So to simplify this, I'm going to expand it. So this C, you have 3 H around it. So H here, another H here. Then this C, then you have H here, another H here. So the H is 2. Then another C, then with 2 H around it. So we are done with this, then we are here. Then over here there is C and there is H, but there is another CH3 down here. So it's supposed to be this way. Now this is a substituent. So continuing, we have C, then we have 1, 2, 3, H here, H here, H here. In my previous video I mentioned that this is an organic substituent. Now to name this, we first of all have to know the position on the number of carbons. First of all, we have 1, 2, 3, 4, 5 carbons. Now on which position? What I mean by position is the carbon number. Now we always use the least number. So let's see, this is 5 carbons. Counting from your left to your right, you have 1, 2, 3, 4. It's on the 4th carbon. When you start counting from your right to your left, it's 1, 2. Now we always prefer to use the least number. So 1, 2, 3, 4, 5. Counting from left to right give us 4, but we prefer to use the least number, so we are going to use 2. So this organic substituent is found on the 2nd carbon. So to name this, when you are naming, you always bring the name of the substituent first. So the position first. So 2. Now since this is CH3, an alkyl group has CN H2N plus 1. Now this one, since it has 1 carbon, we know that one carbon is meth, METH. So this is methyl. Why methyl? Because it's an alkyl group, ALKYL, alkyl, KYL. So 2 methyl. Afterwards, since it's an alkane, you have 1, 2, 3, 4, 5. 5 is pent. So pentane, like an alkane, ANE. So 2 methyl pentane. So we have another structure here. This is a molecular formula. We need to make it a structure. So anytime you see a molecular formula and then there's a structure in a bracket, it's a substituent. But over here, let's see how this works. We have C, and you have CH3. What I mean by CH3 is they are connected to the carbon. Okay, so I need to write CH3 rather. CH3 here, CH3 here, CH3 here, and another CH3 here. Now, this is what we have. We always use the longest chain. Counting from, you can either count vertically or horizontally. So, vertically 1, 2, 3, horizontally 1, 2, 3. Wow. Yes, so we can choose to use vertical. So I want to use vertical 1, 2, and 3. Using this vertically, it means that I have 3 carbons. My longest chain is 3 carbons, and 3 is prop. So we are looking at a propane here. It means the ones you have at the other sides are substituent. Now you have 2 substituents on 1 carbon, and this carbon is the 2nd carbon. Counting from up to down, 1, 2, 3, it's still on the 2nd. Counting from below to the top, 1, 2, 3, so it's still on the 2nd. So since we have 2 substituents, you are going to call it 2, 2. Why 2, 2? There is one here, there is another one here, 2, 2, 2, di. Now in inorganic chemistry, naming of compounds, that's what we met this. When you have the same, that's substituents with the same name, whether they are halogens or they are organic substituents. This methyl, this is also a methyl. That's when you bring di. 2, 2, dimethyl. Now assuming this was C2H5, you don't bring di because they are not the same, although they are the same. They are under the same substituent, that is organic substituent. So 2,2 dimethyl 1, 2, 3. The longest chain is 3. Propane. Now, don't forget that alkanes are made up of single bonds. So once there are only single bonds here, it's an alkane. So this is an organic compound and it's an alkane. And it looks like another step higher. So let's see how it goes. We have C here. And we have 3 H around it. So 1, 2, 3. H here, another H here. So that's for this one. Then this one, you have the C here. Then you have one H here. Then CH3 here. Then C. Then this 2H. H here, another H here. Then this C. And this C has CH3 around it. So CH3, there are 3. Another CH3 here. Another CH3 here. Now, first of all, let's find the longest chain. The longest chain is 1, 2, 3, 4, 5. Because this is another carbon. Don't be deceived. This is not an alkyl group. It is another carbon chain. So let's see. This is CH3, yes, which is not a substituent. It's formed part of the longest chain. So let's see. We have pentane. It's a pentane, and you have one alkyl group here, one alkyl group here, another alkyl group here. I told you when the alkyl groups are the same for this one, see they will die. So here is going to be tri. So 1, 2, 3 is going to be tri. But the first thing we need to do is we need to know the position, counting. And the best place to count from is from your right to your left, because that's the place which will give you the least number. So 1, 2, 3, 4, 5. So 1, 2. So you have 2 alkyl groups on the second carbon. So 2, 2. You're not done yet. There's another one here. 1, 2, 3, 4. So 2, 2, 4. Sorry, it's going to be a hyphen. Now take note that a hyphen always comes between a number and a letter. So since it's 3, it's going to be what? Can you guess it? It's going to be tri. 2 was die. So tri methyl. 2, 2, 4 tri methyl. 1, 2, 3, 4, 5. Pentane. So with this one, we have CH3 here, CH2. So let's identify the alkyl groups. This is the alkyl group. This is another alkyl group. So this and that. So looking at it, counting from our right will be better, or is the right way according to IUPAC nomenclature. So 1, 2, 3. So you have the alkyl group. The first one is on the second carbon. Then the second one is on the third carbon. So this is called ethyl, ETHYL, and this is called methyl, METHYL. Now, since different, what you do is you name them in alphabetical order. So E comes before M. E comes before M. So the ethyl is on the third carbon. So the name is going to be 3-ethyl 2-methyl. Now let's find the longest carbon chain. 1, 2, 3, 4, 5. 3-ethyl 2-methyl pentane. Pentane because only single bonds. Pentane. So our fifth question, we have a halogen, and another organic substituent. So another rule I'll introduce here is that you name halogens first before you name the organic substituent. Yes, but the halogens are different. We have bromine here, we have chlorine here. So to name this is what you do. I mentioned earlier that we always name in alphabetical order. Since you are going to name the halogen first, we are going to name them in alphabetical order. And to do that, we'll start counting from our left to our right. So 1, 2, 3, 4. So we are going to call this 1 bromo. Since it's on the 1, then the chlorine is on the 4. So 1 bromo, 4 chloro. Then this is propyl. And it's found on the third carbon. So 3 propyl. Then our longest carbon chain 1, 2, 3, 4. Butane. So how will you call this? You can pause the video and then try to name it. Okay, so this is carbon and you have 1, 2, 3, 4. Since they're only single bonds, you know this is an alkane. It's an alkane and you have 4 carbons around it. Now, when it was 2, I told you it was di. When it was 3, I mentioned tri. So since there are 4, this is going to be called tetra. Since it's Cl, chlorine, chloro. Tetrachloro. Since it's only 1 carbon, tetrachloromethane. So that is the name, tetrachloromethane. As simple as that. I urge you to like and subscribe if you found this video very helpful, and share with your friends as well.